And this is Swapnil Mittal, and this is my first lab for the class Physics 2211 Section M in spring 2023. This lab is about constant velocity, and we'll discuss something about the experiments. The flow of this presentation is going to be very simple. I'll give you guys some introduction about the lab and discuss the fundamental principles used around the experiment. I've also used an app called Tracker to analyze the constant motion of a cylinder. I used ClosScript and code written in Python to create a computational model for the prediction of motion. We'll be comparing those computational results with the actual observation from Tracker app. I'll also discuss a what if scenario where the axis of motion has been flipped, and we'll discuss some what does it mean questions around what the experiment actually was about. The principles used in this experiment are very basic. Velocity can be defined as displacement upon time, and Newton's second law of motion says that if an object is in motion and no force is applied to it, the object stays in the motion. Basically, if an object has a velocity and no force is applied, the magnitude of the velocity, or what we call speed, does not change, nor does the direction. If an object is at rest and no external force is applied, the object stays at rest. The system follows constant velocity without any change of speed or direction. Here are some observations of the Tracker app. The object started moving in some time, and the tracker started analyzing and drew a graph of the object's motion. This is the graph. This is what the graph looks like. It's a linear graph wherein the distance or displacement traveled changes linearly with the time. The mass of the object was 0.5 kgs. The observation start time was obviously 0. The Tracker app calculated the object's initial velocity to be 2 meters per second, and the time of last observation was 0.124 seconds. The computational model showed a similar model of object's motion. I changed something in the code wherein I've used Newton's second law of motion to calculate the ball's velocity and the ball's position. Here's my ClosScript code if you guys want to refer to what the code actually was and see the observation in real time. There are some errors in this. We have assumed that the cylinder will not drift forward, and also that there are no non-zero forces present, where though friction and drag obviously were present. We have also performed this experiment in lab conditions, and so this might not be completely accurate. If the axis of the motion is flipped, the motion will be in positive x direction, and the object will have a positive velocity. Also, the graph of the motion will be in the first quadrant. The forces in action that cancel out to be 0 were the gravitational force which pulls the object downwards, the normal force, or what we call the contact force, which keeps the object upright on another object, drag, which acted opposite to the motion, and friction, which again acted opposite to the motion of the cylinder. Thank you guys. I hope this was helpful for you, and I have tried to put as much effort as I could into this lab experiment. I hope this is successful. Thanks for giving me your valuable time. Thank you.